Hello and welcome to my tech farm. My name is Igor, and approximately a month ago I was at Hungexpo visiting 3D printing companies, and there I meet a Hungarian company, Filaticum. And there they showed me their filaments, so-called engineering PLA, which can withstand temperatures up to 150 degrees Celsius. And they gave me approximately 10 meters of sample filament, and I tested, and it's really, without annealing, it survived temperatures approximately, it started with the deformation at 150 degrees Celsius. I compare it with the ABS. And then I brought them back that I'm ready to do a deeper research of this filament if they send me a whole spool, and they send me this package, so quite big homework they give to me. What I have here, this is this engineering PLA, but also this is so-called PLA Advanced. They claim, according to the website, that it can resist to temperatures up to approximately 85 degrees Celsius, which is between PETG and ABS, but the printability is like PLA, so definitely this will also be tested. And these two filaments I will test in a separate video, because I want to test them with all my test objects, which I usually do on this channel, so the results are comparable with those which I did in previous or in future videos. And what I have here are the filaments designed mostly for aesthetic look, but not only. This is PLA Model Foam. And I can feel that I have here only sample filament. Here it says PLA Clean, so probably according to the website it is the cleaning filament, which contains some short glass fibers, which will polish and clean the inside surfaces of the extruder and the nozzle. About PLA Model. This is a filament which contains gypsum, 20%. They also have filaments which contains less and more gypsum, but this is somewhere in the middle. And this changes the typical functional and aesthetic properties of the plastic. This material also contains white pigments, which will result a little bit off-white color, and it will result a matte finish. And the details are very outlined, which is useful for the modeling. Few other specifications: printed models can be painted much easier. The object can be sanded both with dry and wet sanding, and it is easy to cut. It is UV resistant filament, and it is one of the most versatile Filaticum product. Now let's see the foam. Objects printed with Filaticum foam has a foamy, spongy texture, and due to the foaming structures, layers are barely visible. However, it can be easily sanded, cutted, painted, shaped as needed. Now, the structure of the foam, quality and structure of the surface can be widely modified by changing the printing settings. And I already have experience with the so-called lightweight filaments. The density of these filaments can be changed by the temperature. So if you raise the temperature maybe to 240, 250 degrees Celsius, in that case the foaming starts and the volume expands. So if you want to have the same volume printed, we have to reduce the flow rate down, sometimes even to 50%, and with this we can have very light materials, very light product. As I mentioned, I already have experience with this kind of filaments, and I know that yes, they are extremely light, but also they are weaker, so their usage is in some modeling or RC planes or something like that. So these filaments are mostly for aesthetic look, but of course they have some functional part too. I will not print all those test specimens. Maybe I will check the layer adhesion and the tensile strength, but mostly I want to see the looks of this printed object. It's packed in this foil, but it is not vacuum packaging, and I cannot see any silica gel inside. There are no useful information for the printing on the spool, only the brand of the filament and the date of the manufacturing. There are holes for locking end of the filament. I'm starting the printing of the temperature tower from 220 to 200 degrees Celsius. Theoretically the lowest recommended limit is 195, but I don't like to go below 200 degrees. It's a good start. I hope the adhesion will be like with the regular PLA, so I'm using here the smooth PI sheet. This is the second element at 210 degrees Celsius, and I can see a little bit more stringing that I would like to see with regular PLA, especially at 220 degrees Celsius, which is the maximum recommended printing temperature. But I will analyze this temperature tower at the end when it's finished. Printing is finished, and just quick check of the bed adhesion. Okay, that's good. I don't think that will be a problem. And if I analyze this temperature tower, I can see a little bit more stringing on 220 degrees Celsius. On 210 it is reduced, and on 200 almost completely disappeared. The overhang came out perfectly on any temperature, and also the bridging. So definitely, except of the stringing, it acts like a regular PLA. And I'm not sure is this stringing result of the moisture, but definitely I would recommend using some vacuum bags and adding some silica gel inside. Next printing will be some kind of figure. First I wanted to print some kind of sculpture, but to make it more useful I print the head of the Mini for my daughter, and this object has a lot of support, so I want to see how easy is removing those supports. And also I'm very curious about the looks of the surface. Looking good so far, those supports are doing their job, and I'm very curious at the end how easy it is to remove those supports, and also I'm very curious how easy can I smooth the surface with the sandpaper. Printing is finished, and let's remove it from the build plate. I can see some minimal stringing here on the top. Now let's remove the supports. But for the feeling it's like a regular PLA, so I don't feel that it's easier to remove it. Now if I take a closer look, this really looks great. The layers are hardly visible, but I want to try, is it really easy to cut this material? So let's try first to do some cutting with this knife. Yes, for the first feeling it can be cut very easily. Next, let's try to do some sandpapering. So for example here where I had that big overhang, or maybe here I have those layer of steps visible and contact with the supports. Okay, maybe not the best sandpaper for this work. Let's try the file tool. Better result I get with this. I could try fix the ears, I also had contact with the supports. For the filling, the sandpaper and the file tool, I have very similar results but with ordinary PLA, but with the cutting I have the feeling that it is easier to cut this material. Now on their website they have very nice animation in Hungarian, but they claim that it is easier for machine cutting and drilling. So I will try to drill this block, it is 100% infill, and I will compare it with this regular PLA. This is 6 mm diameter twist drill. It's melting. I used the same RPM here, but I could see that the PLA melted around the twist drill. And for the drilling, definitely it's true that this model PLA is much easier for drilling compared to the regular PLA. Extremely nice hole I have here. Now let's do some milling. This is 2 mm deep, 5 mm length cutting. The plastic melted a little bit. I'm using the same RPM. Well, yes, definitely the model looks much better compared to the regular PLA. I have here more melted plastic, but the difference is not so big like with the drilling. These are my test objects for mechanical testing. Of course, this filament is mostly for aesthetic look, but I want to do some basic mechanical testing too. Mostly I'm curious about the layer adhesion, but also I will test the tensile strength and the temperature test. The printing is finished and the string is not so strong anymore. Let's remove the objects. Let's check the tensile strength. This test object is printed in horizontal position and the smallest cross-section area is 4x4 mm. And they all broke correctly on the smaller cross-section area, and I noticed that it usually means that everything is okay with the layer adhesion, but let's measure that too. Now let's check the layer adhesion. These test objects are printed in vertical position and the smallest cross-section area is 4x4 mm. Well, they also broke correctly on the smallest cross-section area. For the filling it was quite good, you already saw the numbers, but everything about 20 kilograms I consider as acceptable. I'm just curious about this temperature test. So this is the model PLA and this is just a regular PLA, M10 nut is a small load, and I want to record the temperature of the first deformation, and I will follow the temperature on this cooking thermometer. This is a time lapse of approximately 2.5 minutes and I analyze this frame by frame. Basically I can stop the experiment now. Very similar, both are very soft. So I cannot feel any difference between two. And before I move to the foam filament, I will just do some basic cleaning, but I'm not really sure how can I see the difference in results. So this filament has some glass fibers in it, and I will polish the extruder and a nozzle inside. I will just extrude maybe 10 or 15 centimeters, and I will move to the foam. That's it, I can unload the filament. PLA foam. It's also packed in this foil, it's not vacuum packaging, and I'm also missing some kind of silica gel inside. It has very interesting textured surface, like some kind of sandpaper or something like that for the filling. This was the cleaning filament, and now it's the foam. Instead of temperature tower, I print this flow rate tower on 240 degrees Celsius, and I'm starting with 60% flow rate, and then every 10 millimeters I'm reducing it, so then go to 50 and at the end 40%. And I'm sure I will have a lot of stringing here, because this is the specification of this filament. The progress was good so far. I started with 60% flow rate. The thickness of the wall should be exactly 0.4 millimeters. I want to see on which flow rate I can get that dimension, because don't forget, this material expands on 240 degrees Celsius, and the question is on which flow rate I can get that dimension. And I can see on 50% flow rate it is now highly under extrude, so I think the third element will not be printed. The second element on 50% flow rate is definitely too transparent, so on the third element, instead of 40, I will change it manually to 70%. 5 more millimeters of printing, but I don't have that solid wall anymore, so I will raise the flow rate, I know, to 100% just for testing for last 5 millimeters. Okay, the printing is finished, and first I want to check the bed adhesion, which is okay. Okay, let's analyze a little bit this small box. I started with 60% flow rate and I got a very nice solid wall here. And then on 50% it was heavily under extrude. I'm not sure what happened here. As you can see, it is very transparent. And going back to 70% didn't give me better result. Only back here on last 5 millimeters, back to 100% flow rate and give me similar wall like here. So I'm not sure what happened, but let's measure the wall thickness. First 10 millimeters are printed on 60% flow rate and 0.46 millimeters is the wall thickness. So according to this, I should reduce a little bit the flow rate to get those 0.4 millimeters. As you can see on 50%, 0.32, but the problem is that it is not constant, it's almost transparent. And only going back to 100% give me again that nice solid wall, which is 0.45. So I'm not sure what happened. Is there some small clogging or something like that? So instead of printing some very light objects, I will just test that property that this foam surface basically hides these layer lines, and it will give some very interesting objects and surfaces. I will reprint this figure and settings will be 240 degrees Celsius and 80% flow rate. Well, as I expected, I can see a lot of stringings between the supports and the surface, and I'm very curious at the end how easy we'll be cleaning these objects, including the stringing and the supports. Printing is finished and exactly what I expected. Now let's try to clean this mess. Wow, removing all these supports was really a nightmare. It took me approximately 20 minutes to get to this stage. And so not even the stringing was the biggest problem, but the supports which started from the object and not from the build plate. And I can see here and here two lines, must be some kind of under extrusion, maybe some micro clogging again. But yes, definitely the surface looks really nice and those layer lines are not visible. I'm very curious how it performs if I print it on regular temperature and the flow rate. Let's check the weight. Model exactly 20 grams and the foam 13 grams. And one last test for this video. I want to see what happens if I print foam filament with the regular PLA settings. So currently the temperature is on 215 degrees Celsius and 100% flow rate. And I'm printing my new string test where I have flat, cylindrical and spherical surfaces. So the printing is finished and now let's clean this mess and analyze the surface. And this is the final result, so the surface really looks great. We cannot see those layers, but I'm not too happy with this stringing problem. Another conclusions, well, I really like this model filament, which includes the gypsum, and definitely it has very nice surface, very easy for post-processing, extremely easy to remove the supports. About this foam filament, these types of the filament was never my favorite. Too many stringing I have. There is no chance that we can remove those stringings, but basically my biggest problem with this was the removing of the support is really nightmare. And I also have 2 times some kind of micro clogging, and maybe that's why I couldn't do that test with the wall thickness with the small box. So yes, it really gives a very nice surface, but it's really hard to use it. I think they recommend maybe some bigger nozzle, but even then probably we have more stringing in that case, and the supports will be even harder to remove it. So which one from these two? The model is which I highly recommend. About this foam, well, it depends on your needs, but as I mentioned, not really my favorite. And I'm very curious about their technical filaments, which I mentioned earlier, so the PLA Advanced and the engineering filament, which has extremely nice properties, specifications according to the website, and I hope you will follow me to that video too. Thank you for watching and happy printing. Ta-da.
Ooh. Ooh-ha.